How did Radhanath Sikdar measure the height of the Mount Everest? Radhanath Sikdar was a mathematician and he never climbed on top of the mountain. Actually, he didn't have satellites back then. Neither did he have huge weather balloons from which he could fly up. Okay, so now I am at the level of this Everest or this mountain. So this must be the highest mountain in the world. So how did Radhanath Sikdar actually manage to measure the height of Mount Everest from the land? So we'll try to find that out and find its applications in modern day problems. So he used something called trigonometry. Now trigonometry, the word comes from triangles. So we'll be using triangles, more specifically right angle triangles. So say Radhanath Sikdar used a machine to survey which was say 1 meter tall. Now from there he measured the angle of elevation, which is basically the angle this instrument made with the horizontal. So that angle is theta1. Now why it's theta1? We'll let you know. Now you have to understand one thing. Radhanath Sikdar didn't have any instruments to measure his distance from the foot of the hills or his distance from the peak. So he measured one angle from a given point and then he moved forward a little, say a distance d. Now by a little I mean something that is comparable, that is a small distance as compared to the height of the Everest or the mountains itself, because it's not 10 meters, it's probably 1 kilometer or in the ranges of kilometers. So say he moves the distance d2 dot d, he puts up his instrument again and again measures the angle of elevation from this point, which is again the angle between this line with the Mount Everest, with the peak of the Everest and the horizontal. So now we apply trigonometry. Let this height be h. So height of Everest would be h plus this 1 meter. So we have to find out h. Now there are two triangles, mind it, A, B, C, D. So in triangle A, B, D, this angle being theta1, this is h. This distance say be x. So this is x, right? So I can say tan theta1 equals to h by x, or x equals to x equals to h cot theta1. Similarly, when I consider triangle ACD, this angle is theta2, this is h, and this is x minus d. This distance, since this total distance I have considered x, this is d, this must be x minus d. So we get tan theta2 is equal to h by x minus d, and in similar process x minus d is equals to h cot theta2. Now this, let's name this equation 1, let's name this equation 2. If we subtract 2 from 1, on the left hand side we get d, on the right hand side we get h cot theta1 minus cot theta2. or from here we get H is equal to D by cot theta 1 minus cot theta 2. So as Radhanath Shikdar knew the distance between these 2 points and the angles that he had measured, he just put them and found the value of H to be 8,848 meters. And that is how he calculated the height of the Everest. So when you are considering the sums that you will get in your competitive exams, they will not have that hard angles that probably Radhanath Shikdar measured while trying to measure the height of Mount Everest. So we can follow a few standard rules for that. Those standard rules mean the angles that you will be getting will be either 0 or 30 degree or 45 degree or 60 degree or 90 degree. All these standard values you have to remember. The sine, the cos, the tan. Now there is a simple way of remembering that, but there's an even simpler way of doing heights and distances when you are basing your sum based on these angles. What is that method? The answer is hidden in your geometry box to some extent. In your geometry box, you will find that you have 2 set of set squares. One is a 30 degree, 60 degree and 90 degree. The other one should be a 90 degree, 45 degree, 45 degree. That is, one is an isosceles right angle triangle, another one is just a right angle triangle. Now, in this one, say this side is 1 and this side is 1, then the hypotenuse is root over 1 square plus 1 square, which is root over 2. So that means this is a unit triangle we can consider, whose 2 sides being 1, the hypotenuse is root 2. And the other one, where the angles are 30 degree, 60 degree, 90 degree, in that one, from triangles we know that the side opposite to the smallest angle is the smallest and the side opposite to the largest angle is the largest. So let us consider the smallest side, which is opposite to the 30 degree, to be 1, and let this side be root 3. So this side would be root over 1 square plus root 3 square, which is equal to root over 4, is equal to 2. So we have got 2 standard triangles, one a right angle isosceles, one a normal isosceles of angles 30 and 60, whose sides are 1, 1, root 2 for the right angle isosceles and 1, root 3 and 2 for the isosceles for the right angle triangle. Now you can see that this covers all the angles, the 30 degree, 60 degree, 90 degree, 45 degree. You can ask 0 degree, what is that? Well, obviously sine 0 is 0, tan 0 is 0 and cos 0 is 1. So how do we apply that? That we will find out as we go on to the sums. Let us consider the simplest form in which one can measure a height. From a point on the ground, the angle of elevation of the top of a tower is 30 degree. If the distance between the point and the foot of the tower be 173 meter, you have to find the height of the tower. There are options given: 50 meter, 100 meter, 200 meter and 500 meter. So let's try to find out the height applying the triangles that we just learned. So this is a 30 degree is one of the angles, so the other angles is 60 degree and 90 degree, which is obvious. So we will draw the 90 degree, 60 degree, 30 degree triangle. So this is 90 degree, this is the height of the tower, which is H. This is 30 degree, which is the angle of elevation, and this is 173 meters, given that is the distance between the point. So this is our point of observation and the foot of the tower. Now if I try to do a comparison with the unit one, 30 degree, 60 degree, 90 degree. Now this is 60 degree because obviously this is 90 and this is 30. Opposite to 30 degree is 1. Opposite to 60 degree is root 3. And opposite to 90 is 2. So that means from the unit triangle, comparing this with this one, root 3 is equivalent to 173 meter. Now root 3, as we know, is 1.732. Now it can go on forever. So we see that 173, the first few digits match. So let us consider root 3 as 1.73, sorry, and that is equivalent to 173. So that means 1 must be equivalent to 173 by 1.73, which is equal to 100 meter. Now, if this is root 3, the side opposite to 30 is 1. Now the side opposite to 30 is h here. So that means h here is 100 meter. Done. Pretty simple. What do you say, huh? Let's now up the difficulty level a bit. Aniket is 1.6 meter tall. He is standing 20 root 3 meter away from the tower. The angle of elevation from his eyes to the top of the tower is 30 degree. So what will be the height of the tower? There are options given: 21.6, 23.2, 24.72 and 25.6 meters. Now, how is it a bit different than the previous sum? Well, in this sum, we are considering the height of the person. Remember, when we were talking about Radhanath Shikdar, we had discussed that the instrument that he was using is 1 meter high. That means the distance from the ground has to be measured. So, in this case, Aniket's eyes, or Aniket's height for that matter, is 1.6 meter. So, if I draw a horizontal line from there and then I draw this triangle, this entire height is the height of the tower. This is 1.6 meter. This angle is 30 degree. This is 90 and this is 60 degree. So obviously this much is h minus 1.6 meter, because this part is also 1.6 meter, right? So when we are considering the triangle, we will be considering just triangle A, B and C. We are not considering this part at all. So let's try to find the height of the tower. Now the distance given, oh sorry, I forgot to tell you that there is a distance given between this. Say this is 20 root 3 meter. I should have mentioned it that the distance is 20 root 3 meter in this case, from where Aniket is standing to the foot of the tower. Alright, now let's try to solve this. Again, this is that triangle. Which one? The 30 degree, 60 degree, 90 degree triangle. So 30 degree, 60 degree, 90 degree. This side is root 3, this side should be 1 and this should be 2. So in this one, comparing with this one, the side opposite to 60 degree is 20 root 3. So 20 root 3 is equivalent to root 3, and thus in this triangle h minus 1.6 is equivalent to 1 of the unit triangle. So dividing, we get 20 root 3 by h minus 1.6 equal to root 3 by 1. Root 3 cancelling out, we get h minus 1.6 as 20, or the height as 21.6 meter, and voila, option A is right. Now this is almost similar to the last sum, only we have considered the height also. So this is another application of what Radhanath Sikdar had faced when he was calculating the height of Mount Everest. Thank you all. Now let us do a sum which is similar to the problem, the real life problem that Radhanath Sikdar had faced when he was trying to measure the height of Mount Everest, which was known as peak number 6 at that point. Okay. Anyway, to our sum, Ashima, standing at a point P, observes the angle of elevation of a tower to be 30 degree. Right? Radhanath Sikdar measured the angle of elevation from one point. She now walks 100 root 3 meter towards the tower and finds the angle of elevation changes to 60 degree. So, as Radhanath Sikdar had done, Ashima moves forward and from another point sees that the angle of elevation has become 60 degree. Now that point she measures the distance and it is 100 root 3 meter. We have taken the distance in such a way for our convenience, for the sums convenience, because obviously you will be solving sums in your combative exams and that will require you to do the sum fast, so they will be giving you some convenient value. Now if Ashima is 1.5 meter tall, find the height of the tower. So we are also considering Ashima's height as 1.5 meter, just like Radhanath Sikdar's instrument. So let us now move on with the sum and try to apply the formula from Radhanath Sikdar's that Radhanath Sikdar applied and the triangles that we derived so as to help us do the sum faster. So there are two triangles involved and both of them in the same diagram. Say this is initially where Ashima is and she is 1.5 meter tall. So let the height of the tower be h minus 1.5, as this distance is also 1.5 meter. This is 90 degree, this is 60 degree the second point, and this is 30 degree the initial point. Right? So triangles A, B, C and D. So this is H, this is a H and this is H minus 1.5 meter. Right? Now this distance has been given as 100 root 3 meter. So we have to find this. So we know that pretty simply using Radhanath Sikdar's formula, H minus 1.5 is equals to the distance, that is 100 root 3 by cot theta 1 minus cot theta 2, which is cot 30 degree minus cot 60 degree, which is equal to 100 root 3 divided by 1 by tan 30 degree minus 1 by tan 60 degree, which is equal to 100 root 3 by 1 by tan 30 degree is root 3 minus 1 by tan 60 is 1 by root 3. So that comes to 100 root 3 into root 3 by root 3 square minus 1, which is 100 into 3 by 2, 150 meter. Thus this is H minus 1.5. So that gives us H as 150 plus 1.5 meter, which is 151.5 meter. Now using Radhanath Sikdar's formula, just we found the height of the tower. Can we use do it using the triangle method that we did? Hell yeah, let's try. So The first triangle, this is 30 degree, this is h minus 1.5 meter, and this is unknown. Say this is just A, B and D. And so if I compare with this is 60 degree, this is 90 degree. So comparing with the standard triangles, the 30 degree, 60 degree and 90 degree one, this should be 1, this should be root 3 and this should be 2. So 30 degree, if opposite to that is h minus 1.5, this should be h minus 1.5 into root 3. Why? 1 is equivalent to h minus 1.5, so that means root 3 will be equivalent to h minus 1.5 into root 3. Just plain and simple unitary method. Now in the second one, this angle is 60 degree, this is 30 degree, and this is h minus 1.5, this is 90, and I have no idea what this is and I have to find out. CD. Now comparing with this one again, opposite to 60 is root 3 and opposite to 30 is 1. So this is 1, this is something into root 3. So h minus 1.5, I can just simply apply this ratio, that h minus 1.5 is equivalent to root 3 here. Thus 30 degree opposite, that is CD, in the real life case is equivalent to 1 here, or we get CD is equals to h minus 1.5 by root 3. So this is h minus 1.5 by root 3. Now this distance BC is equal to, from the diagram, BD minus CD, or BC is given as 100 root 3, that is equal to h minus 1.5 into root 3 minus h minus 1.5 by root 3. So BC is equals to BD minus CD, which is 100 root 3 is equals to h minus 1.5 into root 3 minus h minus 1.5 by root 3. So that implies, if I take 100 root 3 is equals to h minus 1.5 common, I get root 3 whole square minus 1 by root 3, and solving it, I take the root 3 to this side, this becomes 2. H minus 1.5 is 100 root 3 into root 3 by 2, which implies h is equals to 151.5 meter. I take the 1.5 to the other side, this comes to 150, and that gives us the height. So any way you want to do, you can solve this sum. This triangles method is applicable to all heights and distance sum that you will be finding or getting in any competitive exams. But that Radhanath Chikdar is applicable only when you are given a sum which has someone moving between 2 points, and the distance between the points is given, or even the height is given and you have to find the distance between those 2 points. I hope the specific application of higher trigonometry is clear and you find it interesting, because we can measure a lot of heights and maybe distances between points we cannot travel physically using this in real life, and in competitive exams, well, you apply these and you find the height so as to get right answers within a limited amount of time. Cheers, mates.